So my name is Emanuel. I'm a PhD student at Brown University, and today I'm going to talk about a project that I worked on last summer while interning at Microsoft Research. And this is joint work with Stephen Drucker, Danyel Fisher, and Rob DeLine. Rob and Stephen are both in the audience today as well. So Squeries is all about creating and exploring and analyzing event sequence data. So why do we even care about event sequence data? And the answer to that is pretty obvious, because event sequences are basically everywhere. So for example, electronic health records can be represented as event sequences. In sports statistics, play-by-play data can be represented that way. And telemetry and log files can be represented that way. And telemetry and log files is what we specifically focused on in this project. So imagine you have a website or an application, and you log all the interactions that users do on that website. So there's a lot of people who have interest in being able to explore this type of data afterwards, right? So you might have UX designers that want to analyze the data to see if there's any interaction problems on the website. You have developers who might want to analyze this data to reproduce crashes or errors. And there's product managers or higher-level executives who also want to look at this data to find out interesting stuff about their website. So let's have a look at an example here. So we might be a company that runs a web shop, something that looks like this, or an application where people can shop for bikes, add them to their shopping cart, buy them, things like that. So you have a lot of people, as we said before, that are interested in analyzing this data afterwards, and not a lot of those people have programming backgrounds or skills to be able to write custom scripts over this data. So if you log all the interactions on a website like this, you might end up with files that are huge that look something like this, where you have some session ID that allows you to group events into different sessions. You have timestamps, and then you actually have the payload of an event, which tells you what the user did on the website. And you might as well also have some user information. So what we wanted to do is we wanted to create a tool that makes this type of data accessible for basically everybody who has an interest in looking at it. So no matter if they have programming background or not, we wanted to be able to have a tool that lets users analyze this type of data. So we're actually just going to jump right into Squeries. So I'm going to do a live demo here, so bear with me. I might have a little shaky hands here and there. So what you can do is I loaded a data set into the tool now that's basically based on this fictional web shop that you saw before. So what I can do in here is I can double tap anywhere here and to create what we call a node. So a node matches events. And since I haven't constrained this node yet, this will just basically match every event that we have in the data set. So what you can do then is you can open up this node here to look at what the actual actions were that we matched here. So you see that, for example, view product and view category were sort of common and frequent events within our system. So then what you also can do, is you can change the aggregation level that you look at, that we're going to look at this data. So for example, you can look at it across sessions or across users. And the reason you might want to do that is because maybe there's a couple of users that use a feature pretty often, but overall it's a feature that doesn't get used all that often. So since you're interested in checkout events, or since this is a shopping website, we're probably going to be interested in checkout events. So you can drag out the checkout bar here, and this now creates a second query where we only match events that have action type checkout. So again, I can look at this. If I open it up in sort of a first level of detail, I'm just going to get some more information about the percentages and the actual absolute numbers of the matched events. And then if I open it up further, we sort of go back to this visualization view that we've seen before. So here, the first view is not that interesting, right? Because we have constrained this query to only checkout events, so we only see checkout events. But there might be other things that are interesting to look at. So we can, for example, look at the time of the day and the day of the week that checkout events happened, or we can look at where the users came from that had this specific, that had checkouts. So there's a whole bunch of different visualizations that you can get to by inspecting nodes like that. So things get a little more interesting when we start combining nodes together to create more sophisticated or complicated queries. So for example, I can use those two nodes and sort of link them together. And now I created a query that looks for all pairs of events where the last event was a checkout event. And what this allows you to do is we can now inspect the first event here to sort of look at what people did immediately before they did a checkout. So here we see that most people added something to their shopping cart before they checked out, which sort of intuitively makes sense, right? And then alternatively, if you're interested in what happened after checkout, we can just move those two around, switch the ordering, and now we see that most people close the application after they checked out, and there are a few that added something to their shopping cart. So if you're interested in those people, we can sort of, again, select and constrain our query further to only people that had a checkout and then an add to cart event. And we can look at the product that they added here, and we see that they added a free gift, so they might run some promotion, or we might run some promotion or something on our website. So let's go back to just a single checkout event. So there's a couple of multi-touch gestures to do copies and things like that. So we might be interested how good our search functionality is on our website. So we create a second node here where we constrain it to search actions. And then we can link those two together to figure out if search led to successful checkouts on our website. And here we see we get 0 matches at all. And the reason for this is probably nobody went straight from search to checkout without doing anything in between. So what we can do is we can insert a wildcard node here that basically matches 0 to multiple events. And now we again get some matches. So the whole query reads now, find me patterns where people did a search, did a bunch of stuff in between, and then did a checkout in the end. So this allows us now to explore again. So we can, for example, look at the query terms that people use in those scenarios. So that's just a histogram of the most frequent query terms that led to a successful checkout. Or alternatively, we can look at the nodes here in between to sort of figure out what did they do between search and checkout. Or, for example, to look at things like how long did they spend in between in terms of how many events or in terms of actual time. Just going to do a couple of more examples here. So do another copy gesture here to do search. So we might want to figure out how good is the search actually. So one way to measure this is to figure out what did people do after they did a search. So we can, again, create a query where we look for patterns that had a search in the beginning and then some other event in the end. We then open up the second node here, and we see that people most frequently looked at the product, and sometimes they did a second search. So we can drag out view product here, link it up here, and then constrain the second one to search. So now what we did here is we created sort of a OR statement where we find out patterns where people did a search and then either looked at a product or did another search. So this just might tell you something about the search, and it looks like it's actually pretty good because most often people find a product or look at a product after they did a search and then do a lot of repeated searching on your website. Final example I'm going to show you here is we might be interested in finding products in our website that people oftentimes confused. And one way to sort of look at this is we want to find users that added a product to their shopping cart and then later on removed that product again from their shopping cart. So what we can do to get to that is we can, again, create a query where we say we want to find people that added the product and then later on remove the product again from their cart. We're going to link those two together. And now since we kind of don't care if they did a bunch of other steps in between, we're going to, again, sort of insert one of those wildcards here. And now we can inspect what kind of products they added, and we can compare this to the products they removed. And we'll see that this is actually not what we want, because if we select now people that added the blue bottle, we see that most frequently they removed the blue bottle again, but sometimes they also removed some other product. So, but we wanted to find patterns where they added and removed the exact same product. So in Squeries, to do those kind of queries, you can link stuff together. So we can say that in the add to cart event here, the first one, the product needs to match the second, the product in the remove action here. So this just creates a link. And now if we actually look at the histogram distribution here, we see that they now sort of overlap. So this now gives us, the whole query is, we want to find people that added something to their cart, did a bunch of stuff in between, and then removed something from their cart, and the product that they added and removed needs to be the same product. All right, so let's take a little bit of a step back here and sort of try to relate and contrast what we did here in terms of related work. So if you think about the whole domain of event sequences and how you can let users explore this type of data, there's basically two approaches you can take. You can either use query languages or you can use some visualization system. And there's obviously a lot of work in both of those approaches. So here I'm just listing a couple of projects from the electronic health records domain where people try to come up with query languages that are good for this kind of event sequence data. And on the other hand, we have visualization systems such as Matrix Wave that was presented on Monday here at the conference that lets users look or find patterns within this type of data visually by just creating visualizations over the data. And we were sort of inspired by both of those approaches and wanted to combine the two approaches into a single system that lets users sort of fluently go from query specification to result visualization. So, and also support sort of those exploratory workflows where you start off with a question, and once you get the answer, this might trigger the next question. I want to talk a little bit about the query language we actually use here. So the whole idea of finding patterns in sequences of data is a pretty well-studied problem in computer science. So if you look at the textual domain, so here I have a bunch of tweets, and if I ask you to find all the hashtags in those tweets, a lot of you would probably intuitively jump to regular expression to do this kind of task. And this is basically exactly what we did here in Squeries 2. We took the concept of regular expression and transposed it away from the textual domain into this event domain. And instead of using those cryptic patterns that you get from regular expressions, we use the nodes that you've seen before in the demo as sort of our base element in the query language. So here are just a couple of examples to show you how the matching actually works. So this is a completely unconstrained node that matches any type of event. And here on the side, I'm just going to show you an example event sequence. So this event will match all of the events that we have here in the sample. And then you can sort of further constrain the event down to, in this case, only events that had an action equal to search. And you now only get the 3 events here in the middle. And we can do this further and say now we're interested in searching, but also in a specific query term. And then you only get back those 2 events here. So you can basically think of those nodes as wildcards in regular expressions with different levels of constraints. And then on top of that, so those nodes are sort of the base element. We implemented all the standard operators that you get in regular expressions. So as you've seen in the demo before, you can concatenate 2 nodes to get to find sequences of two events. Or we have quantifiers such as the star or the plus operator that are used often in regular expressions, and alternations to do branching or OR statements. And then some more exotic features, as I showed you before, for example, the concept of back referencing that comes from regular expressions. So we evaluated this tool by inviting people from 5 different telemetry groups within Microsoft. So what we did is they came in for an hour session, and we gave them a 10-minute introduction on the system on a big interactive whiteboard display, and then let them. So we told them to bring in their own data set. So we gave them a 10-minute introduction and then 50 minutes of time to freely explore their own data set within the tool. I'm just going to go through like the people that we have here just to show that we had a pretty diverse group of people. So there's product managers, developers, data scientists, and about half of them had prior programming experience, and half did not have any programming experience at all. They also came from a lot of different application backgrounds. So the type of telemetry was from different systems. And we interviewed them a little bit about what kind of tools they use today to do this telemetry analysis. And we found that they most often actually use sort of custom written scripts or queries in SQL to do this type of analysis. And then also was interesting to find out that they sort of have different intentions or insights that they're looking after when analyzing this type of data. I'm just going to show you a couple of sort of highlights, anecdotal highlights from that study that I particularly liked. So for example, we had Alice, who's a product manager for an online productivity application, think PowerPoint Online. And she was interested in, or her job is to make sure that they have a good test coverage of their tool. So, and the way she goes about this is she wants to find out the features that are most frequently used and then make sure that they have tests that test for those features that get used often. So one of the things she was looking into by using Squeries on her own data set in the session was she was looking for undo actions that people did on in their tool. So what she found out is that the most commonly undone action is a copy action. And that was super interesting to her because, first of all, copy is not an undoable action. And second of all, she realized that they don't have a test case to test for that specific use case or workflow. So that was just one interesting insight that she got out of using the tool while being in our lab. Then another, they came in as a pair, Bridget, who's a product manager, and Charlie, who's a developer. And I think this was particularly interesting because I think this represents well how this type of telemetry analysis gets done in companies like Microsoft today, because Bridget does not have any programming experience at all, but she has a lot of domain knowledge. She knows the tool really well. She knows what kind of stuff she's looking for in the data. But she can't do the analysis by herself just because she can't write custom scripts. So she usually pairs up with a developer like Charlie and asks him to write those kind of scripts to do the analysis. And during our session, it was interesting because Charlie picked up immediately that the whole tool was based on regular expressions. He knew how to use it. And Bridget took a while to sort of warm up to the tool, but after a while she got into it too, and they started collaborating on the whiteboard and discussing things back and forth. So that was really interesting. And so what they found out by using the tool is they had this one obscure error that happens super randomly in their application, and they realized that it only happens for a specific version of their system. And there's a bunch of those anecdotes that you can read up in the paper. I'm not going to go through all of them. Yeah, if you have any interest, I'll encourage you to look at the paper. So yeah, I want to finish off by thanking my co-authors and Microsoft Research in general. And let's hear some questions.
Alan Blackwell from Cambridge. That's a really beautiful system. Well done on the implementation. It looks fantastic.
Thank you.
It's somewhat related to a project I did a few years ago where I made some visual regular expression languages and then compared their usability to each other. I actually made 4 variants, or at least normal regular expressions as a control, and then 2 forms of visualization, one of which were kind of similar to yours, and we did verify that visualizing the regular expression as the path effectively that an interpreter would take in matching the regular expression was usable for a wide range of people, so you've got some evidence if you want to draw on that. But actually, something we found that you haven't anticipated is that another of our conditions, we didn't use a visual language at all. We just used natural language sentences where we described what it would be like to be the regular expression interpreter accepting that sequence of expressions. We found that that was equally understandable, in fact slightly superior to the visual language that, like you just described, and as fast for people to interpret, and may even be more approachable for end users. Yeah. So something you might like to consider for future work.
Definitely, yeah. Thanks a lot.
Fan Du from University of Maryland. Thank you for the talk. I'm also working on event sequences, and what I found out is that very often our client just give you a data set. They don't know where to start. They don't know what might be interesting patterns of queries. So do you have any suggestion, like how to help people get started?
Yeah, I mean, so there's a little bit of, or there's work on how to extract interesting sequences automatically from big event sequence data. So I think you could sort of combine the two systems, or yeah, include some of those algorithms to sort of give them a starting point. Or if they're stuck at some point, you could tell them, oh, this is the most frequent type of event sequence that people do. So definitely, yeah, we were thinking, but we haven't done any work on that, but we were thinking about combining systems like that.
Thank you.
Florian Block, Harvard University. It looks fantastic. It seems very responsive. I'm interested in the amount of data it can handle. I know that regular expression are really efficient, but for instance, I've got 15 gigabytes of event data of an interactive exhibit. Would it be able to handle that? And if yes, can I have it?
You got to talk to the Microsoft people about that.
Right.
So actually, the prototype does not handle a lot of data that well. So it's all running on the same machine, no parallelization, nothing at all. But we think, or we argue that the visual language does handle a lot of data, right? Because we only show aggregations, and I think parallelizing sort of the back end is pretty trivial to do. Yeah.
Try and make it work.
Will do. Thank you.
Okay, let's thank our speaker again.